Hi there, and welcome to my channel. In this question, we are given function f of x, which is the integral of sine t between 0 and x squared. And we need to find how many points are there in the closed interval from 0 to square root of pi, such that the instantaneous rate of change of f equals the average rate of change of f on that interval, on the entire interval from 0 to square root of pi. So let's first find the instantaneous rate of change. And the instantaneous rate of change is just f prime of x. And so to find that, let's recall that the derivative d over dx of the integral from a, which is a function of x, to b, which is a function of x, of f of t dt is equal to f when we plug in b of x times the derivative of b of x with respect to x minus f where we plug in the value a of x into the function times the derivative a prime of x. And so in our case, the derivative f prime of x is equal to sine of x squared, where we plug in the upper bound of this integral, times the derivative of x squared, which is 2x, minus sine of 0 times the derivative of 0, which is 0. So this is really 2x sine of x squared. So we found the instantaneous rate of change. And what is the average rate of change of function on this interval? So the average rate of change is equal to f of b minus f of a divided by b minus a. And so before we do that, let's simplify the functional form. So f of x is equal to the integral from 0 to x squared of sine t dt. So let's calculate that, and this integral is simple integral of negative cosine t, where we plug in the value 0 and x squared here. This is equal to negative cosine of x squared minus 1 and minus another negative, so plus 1. So this is equal to 1 minus cosine of x squared. And so calculating in our case f of square root of pi minus f of 0 divided by square root of pi minus 0 gives us f of square root of pi. F of square root of pi is equal to 1 minus cosine pi, which is equal to 1 minus negative 1, which is equal to 2. This is equal to 2. And then f of 0 is 1 minus 1. This is equal to 2 minus 0. F of 0 is 0. We subtract 1 minus 1 over square root of pi. So this is equal to 2 square root of pi. So we need to find how many intersections are there between this function and 2 over square root of pi on the interval from 0 to square root of pi. And so we need to find x's from the interval 0 to square root of pi such that 2x sine x squared minus 2 over square root of pi is equal to 0. And so let's pull out our calculators and graph this function and see how many zeros are there. And so we need to find how many zeros this equation has. And so the equation is 2x sine of x squared, close parentheses, minus 2 divided by pi, by square root of pi, by square root of pi. And let's see what window we have. We need window from 0 to square root of pi. And let's graph this. Let's graph this. We'll see how many solutions this equation has. And we can see that there are two solutions on the interval from 0 to square root of pi. And so, as we just saw, the answer here is 2. So there are 2 points on a closed interval between 0 and square root of pi, for which instantaneous rate of change of f equals the average rate of change of f on the interval from 0 to square root of pi. Thank you for watching. If you liked this video, please don't forget to click the like button. Also, write me your comments below and subscribe to my channel, where you can find more solutions to AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.